of deriving formulas. Today we'll look at the reciprocal of a complex number. A complex number is a linear combination of a real number and some complex number I, where I squared equals to -1. How do we solve this? Let's look at the reciprocal of 1 over root 2 plus 1. This is a surd. What do? Rationalize the denominator. So we can use the difference of squares identity to multiply by a fancy one. This is just a fancy one, right? But we're doing it just for us. Root 2 minus 1 over, and then we use the difference of squares identity. Root 2 squared minus 1 squared equals to root 2 minus 1 over 2 minus 1 equals to root 2 minus 1 over 1 equals to root 2 minus 1. There! That's our reciprocal. Now if you think about it, if I squared is -1, then I is the square root of -1. So we can think of a plus bi as a surd. 1 over a plus b root minus 1. Usually we just write I. What do? We multiply by another fancy one. This time, both numerator and denominator has something called the complex conjugate. See, this is called the conjugate. You just flip the sign of the imaginary unit. Simple as that. Complex conjugates are really important. This is how it's important. So when a plus bi is the root of a polynomial, so does a minus bi. This is especially useful when you're trying to solve polynomials. For example, if we have 3 plus 4i, then 3 minus 4i is also automatically a root. Anyway, thanks for the digression. Let's move on. Use the difference of squares identity. A squared minus bi squared equals to a minus bi, and then we can use the distributive law minus b squared I squared. Since I squared is -1, is a minus bi over a squared plus b squared. There, I hope you enjoyed it today. And then in the next episode, we're now going to look at another system of complex arithmetic, similar to I squared is -1, but this time we will see its relation with hyperbolics. See you soon!